Hello everyone, thanks for joining. Welcome to the webinar. This is Building Powerful Apps with KeyLines and ArangoDB. My name's Dan Williams. I'm the product manager here at Cambridge Intelligence. I'll be hosting today, but all the hard work will be done by my colleagues who I'll introduce in a second. Before I do that though, I just wanted to say a couple of things about the webinar. First thing is that you're all muted. You can hear us, but we can't hear you. That's just to keep the noise down, but we really would like it if this was an interactive webinar, so it would be great if you could ask us questions as we go through it. There's a Q&A feature on the GoToMeeting, so if you have any questions, please send them using the Q&A facility. We'll answer those at the end of the webinar, and it would be really good if you could ask questions as you go. The second thing to say is we will record the webinar, and it will be made available on our website a little bit further down the line. But thanks for joining today, and by joining live you get the opportunity to ask questions. So let's get started. As I say, all the hard work today will be done by Luca Olivari, who's the president of ArangoDB, and my colleague here at Cambridge Intelligence, Christian Miles. And I'll let them introduce themselves as they begin their presentations, but you can see what they look like and a little bit about them here on the screen. So all I want to do is set the scene with the agenda today. We're going to start off with Luca. He's going to talk about ArangoDB and the multi-model approach. He's going to talk a little bit about the benefits and why you'd use it, and then we're going to move into the concept of visualization, and he'll tell us a little bit about the advantages of visualizing graphs. After that, I will hand over to Christian, who is going to show you a project he's been working on to visualize its particular case study using KeyLines and ArangoDB, and talk a little bit about how the two technologies integrate and work together. And we expect that's going to take about 35 minutes or so. And we'll then come back for the Q&A, so we'll have plenty of time for questions at the end, and we're aiming to wrap up in about 45 minutes from now. So there you go, last chance, last reminder, please submit your questions with the question panel, and with that I will hand over to Luca.
Great, thank you, Dan. Actually, let me start by saying that most of the work has been done by Kristen because the most interesting part of this presentation is going to be the demo. And then I'm going to go through why ArangoDB makes sense as a multi-model database to be used with KeyLines, and then explain what is the difference between a multi-model database and a graph database, and the importance of connected data as of today. So I hope you can see my screen. So let me start by an introduction about myself, and then a few things about ArangoDB. So I'm Luca Olivari. I'm the president of ArangoDB. I joined 6 months ago, and then I've been an advisor to the company for a few months before, and I've been working in the database industry for 18 years now, and I've been working at MySQL, MongoDB, Oracle, some of the largest companies out there. And throughout my career, I always realized that people were looking for something like ArangoDB. So when I was talking to people about relational databases, they were willing to find a solution that was way more flexible than tables. When I moved to document databases like MongoDB, people were looking for something like MongoDB, so a document store, a JSON document store, but they wanted to find a way to relate documents, to connect documents, to handle complex data as well as complex relationships. So the idea of the founders of ArangoDB is actually to marry the document store, so the JSON document store that you could find in MongoDB, for example, with the graph model that you can find in Neo4j as a pure graph database, and then the key value store, and do it natively. So the idea is really to build a database from the ground up that can support, without additional layers, with one core and one engine, JSON model, a graph model, and a key value store. And obviously, you can store your data coming in different shapes and forms. But the other important thing is also making sure that you can use a single query language to deal with the three models. So even if you can store all of them, but then you have to revert back to 3 different query languages, then you won't be productive. And so productivity and the theme of productivity leads me to our mission. So the mission of ArangoDB is to improve the productivity of every developer on Earth. Why? I was telling my story before, so I've been working in the database industry for 18 years now, and then if you go on dbengines.com, for example, you realize there are 340 different databases. So while the NoSQL products started a movement to improve the productivity of developers, in a sense we can say that they failed because there are too many of them. So they focused on a narrow...
Luca, sorry to interrupt. We can still only see your first slide. I don't know if you are...
Oh, I moved to the next one. So can you see our mission?
We're only seeing slide number 1 right now. Are you sharing the right screen?
Yes.
There we go. That worked.
Okay, but it doesn't work in full screen then.
I think maybe you're sharing the screen without the full screen, but
okay.
we can see it.
Hear it again?
Yeah, go ahead.
Okay, let's use this one, and then. So the productivity theme is really important for us. By marrying the 3 data models, so we can improve the productivity of developers, and that's the idea of ArangoDB. So out of 340 different databases that are available today, by marrying graphs and documents, we can really make developers more productive. So let me just try to explain how, just with an example. So let's say you want to build an e-commerce application. On the left-hand side, you have the classic, so to speak, polyglot persistence solution. So if you want to save your shopping cart, you may use Redis. If you want to save your catalog, so product catalog is generally very flexible in terms of the data model, so the attributes of every product are different. So you may use MongoDB. Then you want to build a recommendation engine, and Neo4j is perfect, and then you want to save transactions, and you may be using a relational database like Oracle. So this is the classic approach. There are different query languages to learn. There are many databases to administer. There is a complex code base because every type of activity you want to do needs to be modeled and developed in 4 different databases. So there is an increased cost, and then the productivity of developers is decreased, actually, because you need to learn 4 different technologies. So the ArangoDB approach, being multi-model, is to provide a document store, so you can store the product catalog in ArangoDB, to provide a key value store, so that you can store your shopping cart, and to provide a graph database, so that you can store your recommendation engine details in ArangoDB. And then obviously it's ACID compliant, so you can even store transactions in ArangoDB. So what are the advantages? You have to learn 1 query language, you have to learn 1 database, your code base becomes much better, so it's easier really to build applications on ArangoDB, and the lower total cost of ownership and improved productivity. But people would say, okay, that's fine, I understand the main points, but I know there are so many databases out there, so how do we position ArangoDB in the middle of 340 different databases? Well, we tried to come up with a graph where on the X you have the data complexity, so how complex is your data, starting from key value on the left-hand side to very complex JSON documents on the right-hand side, and on the Y-axis, you have the relationship complexity. So how interconnected is your data? Again, you start with key value store, columnar, document. Relational are actually pretty good to deal with interconnected data, but then graph databases are really fantastic to deal with this type of data. And then we will come back to that later, because that's really the advantage of using ArangoDB with KeyLines, being able to deal with complex relationships and visualize them easily. So ArangoDB sits in between graphs and documents. So we provide the connectedness of graphs with the flexibility of documents. So the number of use cases and of applications that you can build on ArangoDB are way more than what you can ever build on the single model solution, even more than relational. And we all know how many applications you can build on relational. So what is the advantage? On one thing is obviously developer productivity, and that's the most important thing. So you can build your applications faster and go to market faster, but then is not the only thing. So if you consider about the polyglot persistence approach, where one transaction needs to go through 4 different databases, then you have 4 times the number of servers. You may have 3 to 4 times the number of developers. You need to purchase 4 times the licenses of the database, and so on and so forth. So with a small use case, you end up saving something like 70%. And then, again, the most important thing is also the single query language. So you don't really need to learn SQL, Cypher, Gremlin, whatever language is popular at that moment. So you just learn one language that you can use with JSON, graphs, and documents, and key value store. But then it's still a new database. So somebody may think, okay, I like the idea. You convinced me. I want to give ArangoDB a try. Great. How difficult it is to move from something else to ArangoDB? Well, we have bindings to all of the languages out there, so at least to the most popular. And then the AQL, the ArangoDB query language, is really SQL-like. So if you see on the bottom right, you have on the left the SQL statement. On the right, you have the AQL statement. And for those of you who are familiar with coding, you will see that AQL feels like coding. So you have all the features that you would expect in a development language, but it's still a query language. And it's really human readable. So you can easily understand what's going on. And it's easy to move from somebody with a SQL background to AQL because it's really straightforward. But again, one of the trends that we see in the market is that people are not really deploying databases as they were doing before. So if you want to improve the productivity, if you want to reduce the time to market, you need to find a better way to deploy your systems. So we are working with the likes of Mesosphere, with Kubernetes and Docker to make sure that you can easily deploy ArangoDB on orchestration systems. Actually, if you download the COS, the Mesosphere website, you can get ArangoDB up and running with just 2 clicks, and you can scale ArangoDB from one single node to hundreds of nodes just by a few clicks without having to change a single line of your application. So it's built in a modern way. It supports all the different data models that I discussed. It has a single query language, but there is one thing that we didn't discuss, which is performances. So all of that would be useless if ArangoDB was slower than all the other products on the market. So if best of breed is much faster than multimodal, then all of the advantages that I told you before that don't really make sense to me. So what we've done is we've built a benchmark. It's been released as open source, so you can download and test it and compare the ArangoDB with some of the other competitors or technologies out there. And then in most of the cases, as you can see, ArangoDB is obviously the green line, and 100% is the baseline. So everything, the speed of ArangoDB is 100%. Everything that's above is slower. Everything that's below is faster. So you see that in most of the cases, we can compete with single model databases, and not just on a single node, but also, as you can see on the right-hand side, on clustered deployments. So the small chart on the bottom right is basically a test that we've done with Mesosphere, and then we can scale ArangoDB to 1 million writes using something like 76 nodes or 74. I believe that's the number where we can get to 1 million. So it scales linearly. If you check the blue line, it really shows you that you can scale ArangoDB linearly without any issue, and without, again, changing any line of code in your application. But then that's the technology. So how can you use ArangoDB? What are the use cases? Well, there is an example here. So Bitcoin and blockchain. Why? Because if you think about blockchain, is really a graph. If you want to build a recommendation system, the one below, you are trying to understand what is the relationship between myself and my friends, if my friends are generally buying something that I buy as well, if there are relationships between products that are bought together, and you can think of it as a graph. Then you have geo-aware and localized applications. So you can store geolocalized data in ArangoDB, and you can build something very neat with the technology. So that's very important to understand not just the relationships between your customers and what they do, but also where they are to build applications that are localization aware. Then you have security and fraud detection. Again, try to understand what's going on from a security perspective is generally building a graph and try to identify some strange connections between the nodes to highlight that there is something that's going on there that's not standard. And then you can build everything you want, basically. What I was saying before is by marrying graphs and documents, the amount of applications that you can build is really more than everything else you can do with other products. But if you think about what I said up to now and what we discussed about the use cases, on one end, we are saying that ArangoDB is general purpose. On the other hand, we are always stressing the importance of graphs and the importance of the graph features of ArangoDB. Why? Well, because connected data is really important. So there was a movement in the past where people were trying to store structured, semi-structured, and unstructured data. So the value was in the data itself. Now I can argue that the value is in the connection between documents, in the connections between your data sets and between your data points. So if you want to build a modern application, you need to deal with connected data. And the best way to deal with connected data is actually to visualize it. So the idea of the partnership with KeyLines is actually to work together and make it super simple, super easy to build an application that can deal with connected data and that can visualize it in a compelling way. So without further saying anything else, I would hand over to the KeyLines guys for the most interesting part of this conversation. So thanks a lot.
Thank you, Luca, and hopefully everyone can see my screen now. I'm Christian Miles. I'm the Technical Sales Manager for North America for Cambridge Intelligence, and I help organizations around North America to understand their connected data. That's our strapline here at Cambridge Intelligence. So what do I mean by connected data? So here's just a few more use cases for connected data in a sort of visual sense. So Luca, of course, covered some use cases for graph databases and the multi-model database of ArangoDB. But here are some of the more common use cases that I see working with customers around the United States and Canada. So in the top left, intelligence is a real core use case for graph visualization. So here, what I mean by connected data is that I'm talking about people, maybe places, maybe vehicles and locations, and showing the connections between them, maybe for a law enforcement sense or for intelligence communities around the world. Top right, I have another mention of law enforcement. So here's just an example of looking at graphs over geospatial. So here we're getting an idea of a particular trend of activity in this particular use case. But we're not always just in the public sector. So the bottom left here, I have an example of, say, business intelligence. So here we're looking at drilling into the assets that are either used by a business or maybe the external factors to a business to get a better idea of how they all interrelate and how they're connected to each other. But today, for my presentation, I'm going to be focusing on this use case in the bottom right, which is of an IT network topology. So I'm going to start off and just give you a bit of a background on what I've created and why I think ArangoDB is a great choice for a backend for KeyLines. But right at the end of the presentation, I will give you a live demo of an application I built for this exact purpose. So this leads us into the question, why visualize network topologies? Now, I work with a number of customers around North America, and I think their use of graph visualization in the world of network topologies is typically split up into two categories that I've come up with. First up, discovery. So right here in the middle of the screen, I've given you an example of a network topology. And here we're looking at different nodes, so to speak, or network nodes in a network. And they're visualized with their connections and their interdependencies on the screen. But often, it's very hard to get this sort of view without building this sort of diagram from scratch in something like Visio. But by using something like KeyLines and our application alongside it, ArangoDB, you can actually get a pictorial view or a diagram of the network without having to do that heavy lifting of drawing it all yourself. And once you create this sort of view, it's often the first time that an administrator gets a kind of a nice diagram of what's happening in the network without having to just parse through all of their logs and all their data sources. So the first grouping that I think of when we want to visualize network topologies is the discovery sense, to gain a greater understanding of the network structure. And again, by visualizing it in this form, we can see some quick insights into exactly what the makeup of my network is and what the connections are between all the different components. Then I'd say the other grouping for visualizing network topologies is for our customers looking to defend their assets. And they're looking to defend their assets, which could be either real-world items like the actual devices that are in the network, or it could be the conceptual items that are contained within those devices in the network. So let's say the data or the information that they hold in their organization. And these threats can be of different forms. They could be a cybersecurity threat, so maybe an external adversary, or maybe an internal adversary in an organization, so some sort of insider threat that you want to defend against. But using graph visualization, you can proactively and reactively visualize this data to get a better idea of maybe an alert that's been fired, so that would be the reactive, or maybe proactively spot maybe a network bottleneck or some sort of structural deficiency in your network. So when we look to visualize network topologies and all these other use cases, our application is called KeyLines. So KeyLines, as it says there, is a powerful SDK for building network visualization and web applications. So at its core, it's a JavaScript module. It's client-side, so once you deploy it, there's no need to worry about any extra server-side components. And we have a little breakdown there of all the capabilities or the functionality that we offer. But I do want to just stress one of these in particular. I can't go into all of these, but the flexible architecture is something that we're really proud of at Cambridge Intelligence. So when I say flexible architecture, I mean both the backend. So we're actually data source agnostic. We can work with flat files and disk databases or even relational databases or graph databases. And then we're also agnostic when it comes into the front end. So as a pure JavaScript module, we can be embedded in pretty much any JavaScript framework in the browser, and even on thick clients using some sort of JavaScript wrapper. So if we are data source agnostic in that we don't care about the backend, why is it that I'm talking about KeyLines in combination with ArangoDB? Well, when customers come to me and say, I'm looking to choose a database for my new network topology visualization and other use cases, I often find myself recommending ArangoDB, half for the reasons that Luca's just mentioned in the presentation so far, and half because I really enjoy using it and find it really nice to work with it with KeyLines. So to summarize two of the major points of why I choose ArangoDB when I'm working with KeyLines or I recommend it. First up, the multi-model flexibility that Luca mentioned so far is definitely a key asset here. Instead of having all of those different databases to manage and control and maybe have some sort of broker that talks between all of them and combines all the data for use in KeyLines, instead we can just use the one database and use the Fox framework to glue all those pieces together in a single unified component. And then I also think ArangoDB is quite well aligned with our focus on performance. So we have a cutting-edge WebGL renderer for the browser, which means you can visualize a large number of nodes and links on the screen without any performance degradation. And that fits very nicely with the C++ backend of ArangoDB. So we're looking for a very smooth, unified experience of working between the two. So before I show you my live demo, I just want to give you an idea of the architecture of the combination of these two components. So first up, at the bottom here, we have ArangoDB itself. And for this visualization that I put together for today, it was very simple to get things up and running. I'm on Mac, so I just did a homebrew installation of ArangoDB. We have two separate functions there to allow us to load data and to work with it in Arango. So Arango imp for importing the data, and the shell there as well, so I can actually create the graphs in the backend. I want to take a second just to point out that my KeyLines instance talks to ArangoDB via the Fox framework. And what I've put together is a little service that can be put inside the Fox framework. And this means that instead of talking directly to the database or using an external broker like a little node client that you draw up yourself, instead we can sit something straight on top of the database and use that as a nice routed endpoint for my database itself. There's some great benefits to this. Firstly, I'm much closer to the database itself, so I can reduce the performance lag of having to have a separate component. The other lag that you'd have there with a separate component would be using external, say, Node.js broker, which adds some more network latency. And then the Fox framework is great as well, because in the ArangoDB web UI, I can debug and play with my service that I've implemented to help me debug and test my infrastructure before even getting to the frontline KeyLines component. And then finally, KeyLines is there at the top. So here I've drawn up a single-page web app. That's typically the typical sort of view that our customers draw together. But again, you can use the framework of your choice. So for today, I'm basically just using pure JavaScript, but it's very simple to draw together a UI to show off the capabilities of KeyLines on top of ArangoDB. Now I'm going to jump into my live demo now. I'm firstly going to show you just the Fox framework, the service that I've drawn up that does the communication between KeyLines and Arango. But it's important to note that all my code and all the data that I'm going to show you today is available on request. So I'll show you my email address at the end of the presentation today, and you can send me an email to get the code and the data. Now the data is heavily anonymized. It's heavily inspired by some of our customers' data when it comes to network topology data sets, but it's freely shareable, and I'd love to share it with you so you can get an idea of how simple it is getting KeyLines connected up with Arango for a great seamless graph visualization piece. So as I mentioned, I'm going to jump over first to my ArangoDB web interface. I'm not going to spend too long in here, but first up, I can see I have two collections that I've drawn up. I've got my nodes and my links. Those were imported using the Arango imp tool. If I pop over to my graph tab here, I see I have a network graph instance, and that was loaded again using Arango SH. So I just said use those two collections that I've loaded into the database and use that as the basis for my graph. And then finally, I also loaded my KeyLines Fox service here. And when I say it's really intuitive to use this in the Arango web UI, I really mean it. So if I give this a click here I can see the service that I've loaded, and it gives me a summary there of what it's actually doing. I wrote that. So sends the query to the graph, but then get the response in a KeyLines format. So again, you're not writing any code in the front end for this sort of data kind of parsing or translation to the KeyLines format, which is a very lightweight JSON schema that's required. Instead, all that is being done by effectively the database itself for a very smooth and performant approach to this sort of message passing. My final thing I want to show you here is just the one route that I've set up here. So this is just effectively a URL that I can query to get data back from my Arango instance. Now, if I give this a click, it gives me all the details of exactly what this URL is expecting, and it allows me to wire up my KeyLines application to fire requests over to this URL here. And to give you an idea of how simple it is to test this, what I can do here is I can even test writing queries against that URL in place. So firstly, I'll use the graph that I've defined, which is called network graph. The field I'm going to query against is called ID. The name I'm going to search for is just the ID of 1. And then the depth is the how deep or the traversal in the database that I'm going to go for getting results back. So typing those in there and clicking try it out, I get the boring but very important raw JSON that is going to be returned by ArangoDB itself through this Fox framework. So this data is in exactly the right form for visualization in KeyLines. And so in the future, if I want to make changes to how this looks, instead of having to worry about the client-side deployed web app, I can actually just change the Fox framework itself and maybe do some sort of testing against a separate route, and then update my application to point to the new route. So I really like, as I say, I really like the Fox framework here, and I think it's really great for building kind of modular web apps. And I find the performance is much more preferred over a separate node instance, for example. So without further ado, let me show you an actual application that I built. So this is KeyLines sitting on top of ArangoDB. Again, this is just a single-page web app. So right here in the middle, we have our KeyLines component. We have our core navigation bar over here on the right. I have a watermark here in the top left that I can replace or remove. I want to just note there that it is KeyLines. And then everything else in this application is what I've built for this application demonstration today. So here at the top, I just have some interactive elements for working with the graph as it is shown on the screen. So what's happened here is that I've queried against my network graph data store. And for this demonstration, I'm putting on the hat of a network admin who is under the, basically looking after different campus networks in their university. So I've just queried one of these networks, one of these kind of sub-networks in the university, and I'm looking at, say, the maths department of a university, maybe some sort of department there. So I'm starting off by my initial query point, and this is kind of linking back to what I said about discovery. So I've got here the core part of my network. This is the bridge that is actually going to connect all of the routers and all of the components that are in this subnetwork in this department in the university. I made a quick stylistic decision to actually highlight this with what we call halos. So around the bridge here, which is the component, I just highlighted this with 2 concentric circles. Things are going to get a little more complicated, so I want to always remember where I started from and understand as I expand the data into the screen exactly where I'm coming from. So at the top here, I've actually implemented this little slider bar that allows me to drill into the network into different depths. So if I give us a plus here, we're actually going to drill down and find the directly connected switches that are connected to those bridges there. A couple of stylistic choices here. Firstly, we have dotted and dashed lines depending on different parameters that are connecting these nodes. So the dashed line could maybe mean wireless, whereas the dotted line could maybe mean some connection issue. But also zooming in here, I see that I've set up these little glyphs here in the top left. So these are just little decorations on the nodes. So I've put in a percentage here. What this is showing me is the uptime of this particular node. You can display any sort of information in these glyphs, in these little decorations. And I usually like to reserve them for critical pieces of information. So for example, in this chart here, we see that we have some percentages that are basically showing that the uptime for these nodes is actually quite low. It's not looking too great. So this is a good idea for exactly why I would want to visualize this data, as I want to drill in and find issues like that. Now, as ever, these networks can get quite complicated. So if I click another plus here, I can get all the routers that are connected to those switches, and we've just zoomed to fit that to the screen there. So I can see there's an awful lot more of those little red glyphs, so it's showing me there's a lot of issues maybe in this network here. And then finally, I'm going to do one more plus here and get the final hosts that are connected to all of those routers. So I'm going to rearrange them like so, and using our core layout algorithm, you can easily quickly now spot some patterns in this data. For example, these clusters here, over here on the left, and dragging over here with my mouse, I can look at this one over here, so I can pan around. I can see there's some clusters with a lot of hosts connected to these particular routers. So in a discovery sense, this is showing me that there's potentially some bottlenecks in my network here, or some nodes that are heavily relied upon in my view. So if I zoom back to the whole thing here, maybe I want to have a way of getting to that kind of idea of bottlenecks a bit easier without having to just pan around and drag around on the screen and just spot them myself just with the eye. So one example of how you can do that with KeyLines is I can resize nodes to match their importance in the network. So if I click this Scale Nodes option here, I'm going to resize those nodes, and we've relayed it out to make that a little clearer. So clearly, the bridge here right in the middle is very, very important because it's connecting the whole network, so that's unsurprising. But now I can see that the switches have been resized with their importance with the number of nodes that are coming off them. And now, without having to drill down into the data and zoom in and out all the time, I can easily spot just visually the nodes that are most important to my network here. Let me just turn that off again. And there we can see our original view there. So I think it's quite important to note in KeyLines that we can expose these options to the end user so they can choose these things on demand without having to just overwhelm them with details of enlarging nodes and glyphs and everything else like that. One other example of how we can make that sort of configuration choice is to click on the Show Icons button here. So you may note that these nodes right now as they stand are quite generic. I mean, they're color-coded by their type, but unless you know those colors, I could maybe put a legend on here, but unless you know the colors and look at the text, it's unclear exactly what these are. So traditionally in network charts, we often would use icons to denote the actual nodes that are being shown on the screen here. And helpfully, Cisco actually released an icon pack, which are very commonly seen in this space. So here's an icon pack for all of these different node types of my network here. And you saw there that I turned that on with a simple click of this Show Icons button. It's very easy with KeyLines to make those changes on the fly in the browser. There's no need to do any further requests back to the database, and I can make that stylistic choice there on the screen. I can also save that for my users, so if I have a particular network administrator who always likes to see this icon view, I can leave this on in the future so they always have this view with the host names or the MAC addresses of these nodes on the screen. I'll turn that off again. I prefer having these nodes here like so, and let's see the whole screen here so I can see my whole network here again. Now finally, I want to show you another piece of functionality for KeyLines that our customers really enjoy using and really help them to drill down into their data sources in a way that isn't particularly possible using data analysis techniques using, say, programming languages. Here in KeyLines, I can do a data analysis on the fly, and I can drill down into my data sources using our functionality pieces. So one of those is our combine nodes functionality. So what I can do with KeyLines is I can group nodes by their common connections or common properties or anything I wish, really. I could even allow users to manually group nodes themselves. So in this data set, I've chosen to actually group nodes by their level and their type. So what I mean by that is that you saw how I extended the depth out originally. If I go down a depth, you see that, you know, I have 2 levels there. So I see I have my bridge right in the middle. I have my routers or my switches and then my routers around the edge. But I can bring back those pieces back to the screen right on the edge there. So I have different levels there. But what I want to do with my UI here is to group all these nodes together by their level and the type visually. So if I give this a click here, on the fly, KeyLines will group those all together. And now I get, as I say, a drilled down version of that original view. So instead of showing you all that clutter, all those details of all the nodes that are connected on the screen, this is effectively a topology of a topology. We're seeing those core connections between those different types of nodes on the screen, and then the connections as you drill down in those different levels there. And I can do these groupings by absolutely anything I wish, but I think this is a nice way of showing you how you can show all that same information, but just in a smaller form and just getting a kind of heads-up view of the structure of the network. And then just finally, you see there's an extra glyph here. So this glyph on the top right is denoting the number of nodes that are contained within this collection here. So this node here is a combined node with 10 switches inside of it. Let's say I'm interested in looking into the switch in more detail, and maybe I'm interested in seeing those bottlenecks I saw from early on when I first started looking at this. What I can do with KeyLines is I can drill down into certain combined nodes on demand. So if I give this a double click, I fire up an uncombine option, and there I can see all of those percentages, all those downtime flags for each of those switches there. And again, I'm not expanding out all these others. There's a lot in the network here that I'm not showing. Instead, I'm focusing on switches. And this is allowing me as a network analyst to really evaluate the pieces of the network that I care about seeing and to make decisions off the back of the visualizations that I'm providing to myself. And I think this sort of empowered approach to data visualization is something that we really excel at Cambridge Intelligence with KeyLines. And it's really down to you how much of this you really expose to your end users and how much is useful for your use case. Now, I haven't covered some of our more advanced features like our time bar view, which allows you to look at things in a temporal sense. So you can see how this network may be changed over time. Another popular feature is our map mode, where you can plot all these same switches and machines and routers against the world map, which is also a great way of looking at things in a different dimension. But I think this gives you a nice idea of the core functionality of KeyLines that you can enable. And again, using ArangoDB, it's a very streamlined and a very efficient way to build your application on top of a highly functioning and very flexible database. Now, again, all the code and the data for this are available, so just drop me an email. I'm happy to answer any questions now if you have any particularly technical questions, and we can also take those offline. But maybe just to finish off, let's just bring back this thank you slide here. So there's my email there at the top. We can start a trial of KeyLines, no obligation trial for the professional edition, which includes all the features I've shown you today, as well as the time bar and the map mode. And then we also have a great getting started guide for ArangoDB and working with ArangoDB with KeyLines there at this link here. And then there's some nice links here from Luca. I would definitely recommend this introductory graph course here from ArangoDB. They really start from first principles and basically start from just nodes and links in a diagram and how you can build up your application with Arango. And there's a great community edition of ArangoDB available from the download site there or from Homebrew, as I mentioned earlier. So without further ado, I'll hand back to Dan, and thanks everyone for your time.
Hey, fantastic. Well, thank you, both of you, Luca and Christian, for the presentation and the demonstration. It's a really nice end-to-end view of the whole stack from database to visualization. So thanks very much for that. So now it's time to move on to the Q&A. And just a quick reminder, everybody, if you have any questions, use the Q&A feature of the webinar, and you will be able to send the questions in and ask them of Luca or Christian. So let me bring up a couple of questions. First of all, I can see some people have already asked some questions live, which is fantastic. Let me bring up a couple of questions that were asked when you registered. So many of you asked questions as you registered. So I'll go through these ones first. So there was a question about the advantages of graph compared to other data analysis methods, or what differentiates the graph approach. I think that's really what we've been covering already in the webinar. So I won't answer that one now. If you're not sure, get in touch. We can give you more information. But there's some more specific questions here. So first of all, I guess this is one for Christian. Are there example Fox REST endpoints to support KeyLines? And the questionnaire lists a few of the kinds of things that they're interested in. But Christian, do we provide any examples?
Yes, we do. Yes. So on our SDK site or through our website, you can download an example Fox service. But I've extended that a little further for my demonstration today, and I'm happy to provide that to you. Due to the nature of how you build these, you always probably want to be customizing these for applications. So there's no such thing, I guess, as a kind of bespoke kind of one-size-fits-all service. But I'm happy to walk you through the creation of that and provide the code. And then the one I showed you today has some of those features that I think were mentioned in the question. Things like paging is easy to add, but we have things like query validation and other testing options that are included in the service I can provide.
Okay, great, thank you. So it looks like the second question on the screen is one for Luca. So how does ArangoDB differ from Neo4j in terms of features and scalability? And does ArangoDB have a document store like MongoDB? I guess you touched on some of this already in your presentation, but maybe is there anything else you want to say on that?
Sure. No, I would say that the two technologies are great. So Neo4j and MongoDB are the leaders in graph databases as well as in document databases. So we're talking about best of breed here. But then the idea of ArangoDB is really to marry both natively. So ArangoDB is a fully featured graph database. It scales pretty well, but it also includes the document store capabilities of MongoDB. So it's like that question is the very reason why ArangoDB was invented, to have both technologies together. So we can compete head-to-head with Neo4j or MongoDB if we want to go through the features. By the way, feel free to reach out to me if you have any specific projects. We also have two comparison guides on our website comparing exactly Neo4j and MongoDB. But the value of ArangoDB is actually to keep both models together.
Okay, great. So the next question, I guess, could be applied to both presentations. How do the technologies scale as data increases in size? I think, Luca, you talked a lot about that already in your presentation, but I don't know if there's anything else you want to say on scalability of ArangoDB.
No, I would just confirm what I said before. So you can scale ArangoDB from one node up to hundreds of nodes without changing your application, which is really, really important.
Yeah, and Christian, any comments on KeyLines scalability?
Oh, of course. So so we have a very cutting-edge WebGL component that allows you to visualize tens of thousands of nodes on the screen at any time. But also we have a kind of a toolkit of different ways that you can work with large volumes of data. So whether you're looking at things using the time bar, so you can drill into time periods, so you're not overwhelming the end user or trying to show too much on the screen, or maybe even the search capability that I showed you today, where you start from a particular node and you expand out. So we have great performance using WebGL, but we also have some great techniques for working with large volumes of data as well that can scale. Okay,
great. There's a question there which I can take. We need working samples with ASP, .NET, and so on. Does KeyLines support it? So yes, KeyLines does support it. As Christian mentioned, we're pretty agnostic of your framework and where your data is coming from. We don't have any examples of that on the SDK site, but get in touch with us and we can provide guidance to help you with that kind of integration. So those were the pre-written questions. We have a few questions as well that were sent to us, or being sent to us live. Thanks to those of you who are doing that. First question, are there special requirements on how you store graph data to support a KeyLines chart? Or is it straightforward to incorporate existing graph data that is stored in ArangoDB? And maybe I'll ask that to Christian as you did a working example of this.
So the core idea here, basically KeyLines expects data in JSON, and using Arango import, one of the default import modes is to use JSON there as well. So I think there is a little, as I had to do, there's a little bit of conversion you need to do, and there's a little bit of mapping to the fields that are expected by Arango. But anyone with any experience with data effectively will be able to do this. It's very minimal barrier to entry when you're doing that sort of import. And I do find Arango input to be very efficient and also just very flexible in working with different data sources. So in summary, yeah, there is a little bit of conversion to do, but it shouldn't be too taxing, and Arango imp is very flexible for working with different data sources.
Okay, great. Just a comment on time. We said we'd run for 45 minutes, so we've reached that time. So if you do have to leave now, thanks very much. But we have lots more questions, so we'll carry on answering those and try to get through as many as we can. So the next question, again, this is one for Christian, I think. Is it possible to save a layout of a graph in KeyLines so that a user can return to the view they created at a later stage?
Yes, it is possible. And that is, as it sounds, a very useful piece of functionality and something that most of our customers, I think, implement. So we have a very helpful function called chart.serialize that allows you to save the current state of any particular KeyLines chart. And you can trigger those saves by actions that the user are doing automatically, or you can allow your user to click the save button that you put in your application to save those with maybe a name or something. So yes, that is something that is something that we offer with KeyLines, and it's very simple to add that to your application. One side effect of that is actually a nice undo redo stack that you can implement using that sort of save function. So you can just, whenever anybody changes a view or updates a view, you can save a version, and then you can just undo back to previous versions just with buttons on the screen, which is also great for audit purposes.
Okay. And another one on KeyLines. How does KeyLines deal with the expansion of a node with more than 300 connections? Is there any lag in the UI? I guess you talked a bit about scalability already, but I don't know if you have any tips and tricks about expanding nodes.
Yeah, I mean, that's obviously a big topic, and it's the sort of question that everyone asks when they start to work with large volumes of data. And we have a number of techniques for working with that sort of issue there. So it could be the option that you maybe want to have some sort of cap to prevent people from actually expanding that data, because it may not actually be valuable to have that all on the screen at once. Something else you could do with KeyLines is that before showing all that data, you could actually use the combine nodes functionality that I showed you. You could do that on the fly with the new data being added to the screen. So you can still show it and show the core connections between the new data and the old data, but you're not showing 300 separate components. We also have a new piece of functionality coming out later this year that I want to just tease that will help with that sort of use case. Again, just trying to work with large volumes of data and visualize it in a neat form. So keep your eyes peeled for any press releases from us on that. But just finally, one other thing you should consider there is maybe working with different layouts. So we have some very customizable layout functions. So whether you use layout or arrange, you can start to work with the data as it's being added to the screen in a way that is useful to the end user without overwhelming them. So as I say, it's a big topic, and I'm happy to walk you through what I just mentioned, but there's a number of ways that you can work with that sort of large expansion.
Okay, one for Luca perhaps. Can ArangoDB work on multi-domains?
Yeah, I saw that. I'm not really sure if I understand what's meant by multi-domains. So it's probably better to take it offline. I'm not really sure if I get this.
Yeah, no problem. The contact details are there if anyone wants to follow up on that. There's another question about, does Arango handle transactions for all three models of data?
Yes, so the point is ArangoDB offers ACID transactions. So it's fine to use transactions on the models, on every model. What we don't have at this point is distributed transactions. So if you have a distributed cluster, then you don't have the ACID capabilities on the distributed model, but you can run ACID transactions on a single node. And they can span multiple operations on multiple collections using the different models.
Great, thanks. Someone asks, is the recording made available? And yeah, we do try to record these and make them available a little bit later down the line. It takes us a little while to process them, but it should be up and available on our website in the near future. One more question we have. I guess this is a question either of you really, but I worked with Neo4j and found it very difficult to load conditional data, as if else is not easy to implement in Cypher. How is it with ArangoDB? Maybe I'll ask Luca first.
Sure. Yeah. So as I was saying about AQL, which is, let's say, the equivalent of Cypher in ArangoDB, it feels like coding. So loops like if then else can be easily implemented with AQL. So I'm not an expert as how to implement if then else in Cypher, but it's pretty easy to implement it in AQL.
Okay, great. I think that's all the questions we had. I don't see any more, so that's perfect. This is probably a good time to stop. So thank you very much, in particular to our presenters, Christian and Luca, and thanks very much to the audience for joining us. And we hope to see you again at another webinar in the near future. Thanks very much. Bye-bye.
Thank you. Bye.